You have a question? No? Okay. Okay. So let's look at more precisely what does it mean by scattering by examining the special case. As I illustrate over here. Okay. One thing I missed for this case. The good radiation occurs over here, right? And that means wavelength is large. Wavelength is large compared with the size of the plate then in this region, right? So if the size of the wavelength is very, very small compared with the plate size, then it does not radiate. Okay? So effective radiation always occurs when the wavelength of interest is large compared with the typical size of a radiator. Okay? That was also true when we consider the case for the breathing sphere and the traveling sphere. Okay, let's denote this is normal vector. And I assume that the wave is coming in certain direction, like this. Okay, and I denote this is instant wave, and that has magnitude B and the exponential J, K, R. K is the wave number. Okay. And then the total sound field would be composed by two components. One is incident wave, and the other one is scattered field. Right? There will be some scattered field and a PI. Right? And our objective is what is PSC for the given PI and the scatter. The existence of a scatter can be expressed as what? Spatially distributed impedance mismatch. Taking for the special case, if this scatter is rigid, that means normal velocity in this direction is 0. Okay? Maybe not in general case. In general case, for example, if the scatterer's impedance has a real part and imaginary part, then this would not be 0. But for the special case, to start with the simplest case, let's assume that this is rigid. Okay? And frankly speaking, I cannot drive the solution when UN has a real and imaginary part. It's very complicated. I tried several times, but it's very hard to get a general solution. Maybe you guys can try it. In fact, in appendix, you will see a lot of good derivations, right? Amazing derivations. And I must say that about 80%, I don't know, maybe more than 80% of the derivation were done not by myself, but one of a very smart, my ex-student whose last name is Nam. Kyung-Uk He did all the derivation concerning the diffraction and scattering using complex variable. Okay, then what I can say, objective is to find the PSC. That means mathematically means that I need one more equation, right? Of course, those satisfy right? That satisfy this. Plus boundary condition, that is UN is equal to 0 on S0, that I said this is S0. So it's what essentially we are doing is we are solving same equation. Right? What we did, for example, when we have a limp war, we have incident, reflect, transmitted. Incident, reflect, transmitted satisfy this equation. And we apply the boundary condition. What was it? The velocity has to be continuous and pressure has to be continuous. In this case, the boundary condition is a function of x and y. All the other things is the same. Right? So let's do it. Rigid boundary condition requires rigid boundary condition requires what? PT, that is the total pressure gradient on S0 has to be 0. Because gradient P is related with so using Euler equation I can argue that del PT on S0 is 0. In other words, that is expression of a rigid boundary condition. That means PT dot N is 0. Why? Because fluid is inviscid. Fluid particle velocity normal to the surface has to be 0. That is the rigid boundary condition. That's why I use the dot N. Dot N simply means that I'm taking the velocity in the direction of N on S. That means Pi plus PSC dot N is equal to 0. And note that Pi is assumed to have magnitude B and JK dot R. So plane wave. Propagating in which direction? K direction.